We're going to be dealing with other roots now, and we're going to rewrite radical expressions using rational exponents. Remember, rational just means it's a fraction. So we're going to have exponents that are fractions, and we're going to talk about how to simplify those. And we'll simplify and evaluate radical expressions and expressions that have those rational exponents in them. So to help us, when we get to some of these perfect cubes, perfect fourth roots, okay, I asked you guys to find the following list. So the third roots, okay, these are the perfect cubes, are generated from doing 1 to the third power, 2 to the third power, 3 to the third power, 4 to the third power, and 5 to the third power. Were you guys able to do all those without your calculator? Okay, so this is the list of perfect cubes. So we want to recognize those when they are inside of a radical. For example, if you had the cube root of 1, you would want to simplify that to 1. If you have the cube root of 8, you would simplify that to 2. The cube root of 27, you would simplify that to 3. The cube root of 64 would simplify to 4. And the cube root of 125 would simplify to 5. Okay, so this is the format that you're going to see them in. Okay, and then were you guys able to start generating the fourth roots? So 1 to the fourth is 1. You guys know 2 to the fourth? 16. 3 to the fourth, really, 3 to the fourth is just like what times what? That, yes, or, so remember that 3 to the fourth is the same thing as 3 squared times 3 squared, right? Because you add the exponents together, so yeah, what's 9 times 9? 81, so you could do that right away. Okay, and then 4 to the fourth would be like 16 times 16. Do you guys know what that is? 256. And then 5 to the fourth would be 25 times 25. Do you guys know what that is? No, but you're 625. And it's okay if you need to use a calculator to check those. But now these are our perfect roots, okay? These are the perfect fourth roots. Now, if you had the fourth root of 1, if you were taking it, there's something special about the fourth roots, and that's that you could have a plus or minus, because anytime you take the square root, remember how you have to put the plus or minus? That happens with any type of even root. So this could be a plus or minus 1. The fourth root of 16 could be a plus or minus 2. Plus or minus 3. Plus or minus 4, plus or minus 5. Okay, the cubes, if they're positive, the answer is going to be positive. But remember, you can take an odd root of a negative number. So this, if you had a negative underneath, you could have that as well. Okay, and we'll be talking about those types of situations today. All right, let's talk about the fifth roots. And feel free to get your calculator out if it's not. So 1 to the fifth, 2 to the fifth, 3 to the fifth, 4 to the fifth, 5 to the fifth. Okay, so I'm going to give you a minute to calculate those. And I will give you a minute to calculate the sixth roots as well. first two we should know. 1 and 2 to the 5th is. You guys know 2 to the 5th. Okay, and for those, you guys can go ahead and move these. These are the perfect 5th roots. So if we're thinking that we want to do something like this without a calculator, just cut it in half. What's 2 to the 3rd? 2 to the 3rd. 8. 8 times 8 is? Yeah. Okay, and then so these are your perfect 6th roots. Okay, and we are going to stop there since this is a game of patterns, okay? So no matter what root you have, you can always solve using very similar steps. Now, anytime it's even is when you take into account the plus or the minus. Okay, but this is a great start as we start to talk about different perfect roots. Now, every radical has what's called an index. Okay, every radical has something that is called an index. Okay, and you can find the index right here. So this would be the nth root of A. Okay, and then we would say that n is the index. Say the index slash root of the radical. Okay, for this particular one, we would say it's the nth root. Okay, so this is the nth root of A is how you pronounce that. The nth root of A. N is the index and the root of the radical, so it would be the nth root. Okay, for a cube root, what would the index be? For a cube root, it would be, what would the index be for cube? 3. Okay, and then if you had a 4 here, the 4th root, the index would be 4. Okay? Now, I said, what does it mean if there's no index? Really what I mean by that is, what does it mean if you can't see the index? For example, we dealt a lot with this guy. What's the index for this? It's a square root, yeah, so the index would be what? 2. So if you don't see an index value, if you don't see an index value, it's a square root, which you already know. It just means that your n value is 2. Now, when we practice with all these different index numbers and different types of radicals, sometimes people get caught up in that pattern and they try to write something like this. That is a no-no. You do not write the square root like that. Okay? You need to write it properly. It is the square root of A. Okay? Don't write the 2 there. That's not correct. Okay? This is what you want to write. Okay, now the number and types of roots that a radical has is related to the index number and the radicand. Do you guys remember what the radicand is? Yeah, the number underneath. Okay, so that's what we're going to look at for this. So the first one is an odd index. If you have an odd index number, that would be like the cube root or the fifth root. There's only one real root. Okay, so it's either positive or negative depending on what you have. So this says the real third root of 8 is 2. Okay, what that means is the cube root of 8 is equal to 2. If it was the cube root of negative 8, that would be fine too. That would only give you one value. Now the even index, there are 2 different cases. Okay, you can have a even index and a positive number underneath, or you can have an even index with a negative number underneath. If it is a positive number underneath, then you have 2 real roots. So if you were to do the fourth root of 16, you would have to take into account that it's the plus or negative 2. But if you had a negative, there would be no real roots, right? What type of roots would that produce? Imaginary. So this is just the real roots. So if you tried to do the fourth root of negative 16, there would be no real roots. And then let's not forget about our buddy 0. If you take any root of 0, there's one root and it's 0. So this one says the cube root of 0. This is going to be true no matter what root it is. So if you have the cube root of 0, that is 0. If you have the fourth root of 0, that is 0. Okay? Any root of 0 is going to be 0. Okay, so for example 1, it says to find all of the real roots. Okay, so we can use that chart to help us. A lot of this is going to be very natural to you though. So if you have the 6 roots of 64, the 6 roots, that's going to be an even number. 64 is positive. So if it's even and positive, you should have 2 real roots. You have to find them. So the 6th root is 64. Is that something that's on our chart above? Yeah, what's the 6th root of 64? Yeah, it's 2. But this one will be what though? Yeah, plus or minus 2. Okay, so keep in mind you do need to have your 2 real roots. That's what they are, the plus and the minus. Okay, if you're doing the cube roots, okay, then that's going to be odd. This is going to be negative. Now, for the odd index, there's just one real root. So the cube root of negative 216, okay, we don't have the 216 on our chart. We're gonna talk about
Ms. Whipple,
Hi.
can you send Julianne to the constant office, please?
Yep.
Thank you.
So you have the cube root of negative 216. I'm going to show you how you can do this on your calculator as well, so you can check your stuff. There is a cube root button, it's just hidden under math. Okay, so this is going to be the cube root of negative 260. And then you get negative 6. And then because what's underneath is negative, this is going to be negative. Okay, so it's one real root, and it is negative. It's going to follow the sign that you have. Okay, so now we have the fourth roots. Those are even. This is a negative. So if you have an even index, a negative radicand, you know right away there's going to be no real roots. This isn't even a perfect fourth root. Oh, sorry, I need the negative. Okay, so you put the negative there, and no real roots. Okay, so you can't take an even root of a negative. Odd roots are fine. Okay, it's the even roots you have to worry about. It does say roots. It kind of looks like rats, doesn't it? Okay, so no real roots. No rats either. Okay, so with the odd, it's fine because you can have an odd amount of negatives and get a negative. But if you have an odd amount, if you have an even amount of negatives, what happens when you do a negative times a negative? You get a positive. So that's why you can't have a negative under that radical. Okay? All right, we're going to talk about some properties of radicals. This chart in particular are full of properties that you've already known and been using. You just didn't realize they were so official. So the properties of radicals, we're going to look at the properties of the nth roots. You usually have something that starts off with parameters. Okay, so you had a lot of these information boxes when you were doing geometry last year, because you had a lot of theorems, okay, and you had to make sense of what they were telling you. So this says for A is greater than 0 and B is greater than 0. What are they telling you about A and B? Yeah, they're positive. That's all that this is saying, is that in order to use these, A and B are positive values. Okay, when you have negative ones, you have to be careful because of the rules of the roots above. Okay, but the product property should be very familiar to you because we've been simplifying radicals. So the product property says that the nth root of a product is equal to the product of the nth roots. Here's an example. If you have the cube root of 16, you can break that up into the cube root of 8 times the cube root of 2. Because 8 times 2 is what? 16. So you can break them up. Now, the reason we want to do that is because what is the cube root of 8? 2. So just like we were simplifying perfect squares, we're going to simplify perfect cubes, and perfect fourth roots, and perfect fifth roots. Okay, so we're going to have that simplification going on. Okay, so you're just rewriting any number as the multiplication of those two numbers. So rewrite as multiplication. That's fine. Okay, now in the quotient property, remember quotient stems from doing what operation? Division. So a lot of times the quotient property is associated with a fraction because a fraction is division. So just like we can split this up, we can split up the fraction into the numerator over the denominator. This is a square root, so this is something that we've done before. You can take the square root and simplify, take the square root and simplify. Okay, so if you do have a fraction, you're going to rewrite as division. Okay, so always split it up into the root of the numerator over the root of the denominator. Okay, so the root of the numerator over the root of the denominator. Okay, and then sometimes something very nice like this happens, where you can take the root and it becomes a whole number. And the reason why that is nice in particular is because sometimes that doesn't happen. What if the denominator contains a radical? What do we have to do? You guys remember what it's called? We have to do what? It does start with an R. Yeah, rationalize. Okay, so we rationalize the denominator. Alright, so let's do a practice round of that. Okay, so if we had 2 over the square root of 5, we would want to multiply the top and the bottom by what? Okay, good. So square root of 5 over itself. Now, the reason why we can do that is because if you multiply by something over itself, what do you get? 1. And if you multiply something by 1, what do you get? Itself, the same thing. So mathematically, I'm not changing anything. I'm multiplying by 1. Okay? So this is a way to manipulate what you have so that the denominator simplifies. Now, I know you guys know what the denominator is. You can tell me. 5. Okay? Let's talk about why it is what it is. Because whenever you have a square root, okay, a lot of times we think of this as the square root of 25 or the square root of 5 squared. Okay? So the 2, which remember, if we don't see an index number, it's 2. So the 2 and the 2 happen to do what to each other? They cancel out. And that's why you're left with 5. That's why perfect squares are what they are, because you can rewrite it as a power of 2. 16 is a perfect square because 4 squared is 16. Okay? All of those perfect numbers are generated from that multiplication. Okay? So we're going to keep that in mind as we journey on into the land of radicals. Alright, so let's look at example 2. Look at this sunshine, you guys. Isn't it nice? Okay, just need a... Just me. It's nice, isn't it? Can it be both? Alright, so we're going to simplify each expression, and it says assume all variables are positive. So this word simplify in math means so many things, okay? When we're talking about it in this section, simplify means that you're going to have to reduce any fractions or radicals. You're going to have to rationalize if there's a radical in the bottom. And you're going to have to pick out those perfect roots. You're going to have to simplify perfect roots and not just square roots. We're going to have cube roots, fourth roots, fifth roots. Okay, and then what's really nice about this is it says assume all variables are positive. That means if you're assuming they're all positive, then you don't need to put the plus or minus like we did on the first page, okay? So you don't need to put the plus or minus for the even roots. Okay, because we're assuming all the variables are positive, so that means they're always going to result in a positive, and it's the even roots where you could get into those imaginary values. All right, now, I believe this may be your first encounter with a root of this type. The fourth root of 81x to the 12. Have you guys ever done something with the numbers and the variables in them in a non-square root? Yay! It's learning something new. Okay, so just like we talked about earlier, let's just split this up. Let's deal with the numbers and then with the variables. Remember in the last section how numbers and variables have different rules? So like if we had, don't write this down, just pay attention. Okay, so if we had something like this, right? 30 over 40, x to the 5th over x squared. In terms of the numbers, what would we do? Yeah, divide by 10. So reduce that with a number that goes into both. And then what would we do here? Subtract. So 5 minus 2 would be 3, so it would either be like this, or it would look something like this. Similar to what we did in the earlier sections, the rules with numbers and the rules with the variables are going to be a little bit different. So let's split this up into the fourth root of 81 times the fourth root of x to the 12. And we'll simplify each one separately. Now, before we get going on simplifying the fourth root of 81, let's go back to when we were simplifying square roots, right? Let's say we were simplifying the square root of 12. Remember how some of you would make those factor trees? So when you were doing the factor trees, right, 2 and 6, and then 6 breaks down into 2 and 3, what were you looking for to know if it comes out of the radical? A pair, right? Because it's a square root, so you were looking for 2 of them. So you had a pair, that goes on the outside. This guy doesn't have a friend, so he has to stay inside. So 2 root 3, okay? That's how you would simplify it. So with this, now you're looking for how many? 4, okay? So let's break this down. Some of you may start to notice like the perfect ones right away, but we're starting out, so let's break this down into 9 and 9. This breaks down into 3 and 3, 3 and 3. Do we have a group of 4? Yeah, so another way you can think of this is the fourth root of 3 to the 4th. And what happens with the index and the power? They cancel, so you're left with 3. So this simplifies to 3. That's going to be part of your final answer. So I'm just putting equals 3 as part of my final answer. I'm going to show you the quick way how to think of how to do how to simplify that variables, and then I'm going to show you how it works. So when you're doing this on your homework, you're going to be able to do that part in your head. We're just going to write down why it works the way that it does. So this is what you want to ask yourself. You want to ask yourself how many times does the index go into the power? So in this case, how many times does 4 go into 12? And what's the answer to that? 3. So this is going to simplify to x cubed. And this would be your final answer. Okay, Now, another way that you could think about that, remember, you're trying to get to a power of 4. So if you had the fourth root of x cubed to the fourth, those would cancel out and you'd be left with x cubed. There are 4 groups of 3 in there. Remember, when you have a power to a power, what do you do with the exponent? You multiply. So I wrote it like this so you could see, oh yeah, the 4's are going to cancel. I'll be left with x cubed. Okay? You don't have to write it like that in your homework. You can just say 4 goes into 12 3 times, so it'll be x cubed. All right, do we got that one, you think? All right, let's try, I want you to try this one without me. So the fourth root of 16x to the 4. And then make sure that you are making your index numbers and roots the same way that I am. I'm looking around and a lot of you are, so that's excellent. Sometimes people get a little crazy when it has to do with the index, and they start writing it like this. Don't do that. Okay, so it has to be a small number there. Like I said, it looks like you guys are doing a good job for the ones that I checked. So you do have to write the fourth root like this. It's not this. This means 4 times the square root. That's your no-no. Yay, no. Do some of you know the fourth root is 16 off the top of your head? 2, because 2 to the fourth is 16. If not, let's just break it down. So 16 is 4 and 4. That's 2 and 2. Okay, so that means 2 is going to be part of it. So I have 4, right? 1, 2, 3, 4. So 2 comes out. And then how many times does 4 go into itself? 1 time. So 2x is your final answer there. Okay, now those are a couple examples of where it went in evenly. For this one, we have the cube root of x to the 7th. So you're still going to ask yourself the same question, okay? How many times does 3 go into 7? Twice. How many are left over after it goes in there twice? 1, okay? So I'm going to write this visually for you on our notes. And then once you're practicing this, you won't need to write all this down. But you have 2 groups of 3, and then you have 1. Remember, when you're multiplying by the same base, what do you do to the exponents? You add them. And that's what some of the things that you just did in the last section. So 3 plus 3 plus 1 is 7. But of course, when you go to simplify this, the cube root of x cubed is what? X. Okay, so the cube root of x cubed is x. The cube root of x cubed is x. And then this one has to stay inside. What's x times x? X squared. So your final answer is x squared cube root of x. Okay, so make sure that your final answer is written properly. And again, that just comes from, okay, 3 goes into 7 twice, 1's left over, 2 can come outside and play, 1 has to stay inside. Okay, so you need a group to come out. Alright, let's try some division. So division is going to be fractions. So you have the fourth root of 16 x to the 8th over 5. Do you have any questions for me on part C?
Where like when the roots cancel out, would it be
Yeah.
like the top and then the one inside that cancel out?
Yes.
So
Yep,
why would
be like this and this. So then you'd be left with x.
So then why would you like just leave like that one? Like the one.
Oh, so this one, see how it doesn't have the third power?
Oh,
Yes. So the only way it can come out is if it has that power 3. If it's anything less than 3, it'll stay inside. That's a good way, too, to check to make sure you simplified this all the way. If you have anything in here that's 3 or above, it needs to come out. So whatever's left inside should be lower than the index number. Okay, now when you're dealing with division, the first thing we're going to do is we're going to rewrite this. So the fourth root of 16x to the 8th on top over the fourth root of 5 on the bottom. Okay, and then let's go ahead and simplify the top, and then we'll talk about the bottom. So the fourth root of 16, do you guys know what that's going to be? So you can ask yourself, yeah, what number to the power of 4 is 16? 2. Okay, and then how many times is 4 going to 8? Twice. So it would be 2x squared on the top over the fourth root of 5. Now, we can't have the fourth root of 5 in the denominator. So what do you guys think we're going to multiply by? So in the past, yeah, so the fourth root of 5. How many of you think we're going to multiply by the fourth root of 5 over itself? Jack, do you have a different idea? Do you have a different idea? Your hand wasn't up. No? Okay, so somebody who didn't have their hand up, do you guys have a different idea? Yeah?
It could have something to do with the fact that, so if those cancel out on the bottom, if you just did times the square root of 5, then it's...
Yeah, then this would be the fourth root of 25. Is that going to be a whole number? No. So remember, the reason why this would cancel out if it was a square root is because, remember we wrote this down, it was 5 squared. So the square root cancels out with 5 to the squared. How many 5s do you want together to cancel out with the fourth root? 4. So what do I have to multiply by? 5 to the what power?
4.
So this is, you already have 1 5. So how many more do you need for a group of 4? 3. So you're going to multiply by, and I'll talk about that again. So you're going to multiply by the fourth root of 5 cubed. So depending on what your radical is, what you're multiplying by is going to change. Remember that if you already have 1, okay, 1 plus 3 more is going to be 4, which is going to be great because when you have the fourth root of 5 to the fourth, what happens? That's where it's going to cancel out, okay, is once you have that. Now, when you multiply across the top, you do want to rewrite this. So 5 cubed is what? It's 125, so this is the fourth root of 125. Okay, and we know that the fourth root and 4 undo one another. So our final answer is going to be 2x squared, fourth root of 125 over 5. Okay, so some of these answers are going to look a little messy, right? They're not going to be just given whole numbers here, and that's okay. Alright, so based on that, now you simplify this. So the fourth root of x to the 9th over 3. Okay, so I want you to start that the same way. Use this as your guide. your first step should always be to break it up into the numerator and denominator. Okay? If you're not sure how to simplify the numerator, let's see if you can find what you multiply by. Okay, so once you split it up, when you're simplifying the top, you're just asking yourself, how many times does 4 go into 9? How many times? Goes in there twice, with how many left over? 1. So if it goes in there twice, it's going to be x squared on the outside, and then the 4th root of the 1 that's left over inside. Okay? And then on the bottom, you have the 4th root of 3. So if you're going to cancel it out, what did you decide to multiply by? The 4th root of 3 to the 3rd. So 4th root of 3 to the 3rd. Because again, that's going to give you 3 to the 4th. Okay, so the whole reason why you're doing that is so that when you multiply those, you have the 4th root of 3 to the 4th. You want those to cancel. Bless you. Okay, so then when you multiply, the rule is you can multiply what's inside the radical to what's inside the radical, and what's outside to what's outside. The only thing that's outside in the top is x squared, so that's going to stay outside. Now the 4th root of x, this is 3 cubed is going to be what? 27. So this is going to be the 4th root of 27x. And then the top, or the bottom, will just simplify to what? 3. Okay, so you do want to make sure that you simplify that 27 there. Have that one go. We'll definitely be doing some more practice tomorrow, okay? All right. And the next thing we're going to talk about are rational exponents. And again, the word rational just means what? What does rational mean? Fraction. Okay, so these are exponents that are fractions. So this says for any natural number n and integer m. Do you guys know what the set of natural numbers are? They're the counting numbers. So when you count, you start with what? 1. So, yeah, because you start like 1, 2, 3, 4. Okay, and the integers are the positive and negative whole numbers and 0. So we've actually talked about this before. The exponent 1 over n indicates the nth root, okay? So we're gonna write that out. The example they give you is 16 to the 1/4 is the 4th root of 16 equals 2. But when I say that we talked about this before, we talked about it with the logs. So if you have a to the 1 over n, that's going to be the nth root of a. What we talked about is if you have a to the 1/2, that's what? Square root of a. A to the 1/3 is the cube root. So we wrote a special note on one of our log sections in chapter 4 to remember what those are going to be equal to. Okay, and that works with any value for n, with 1 on the top. Okay, the next thing we're going to talk about is You don't have to have a 1 on the top. Sometimes it's a fraction, m over n. And that means that you do the nth root raised to the nth power. You do the nth root raised to the nth power. Okay? And there are two different ways you can write this. We're going to highlight this, but we're going to actually write it out and look at some examples to make that click for us. Okay, so here's an example. If you have 8 to the 2/3, okay, one way that you could write this, 3 is the root, so the cube root of 8 squared. What is the cube root of 8? 2. So 2 squared is going to equal 4. So this whole thing would be simplified. Okay, so we're gonna do some work with that. This fraction here, you have a denominator, and the denominator of the rational exponent becomes the index of the radical. Now remember, the index is also the root, so it becomes the root. Okay, and we know that anytime we see rational, we're thinking, okay, that means that all that means is it's a fraction. So there's two different ways you can write this. So you have a to the power of m over n. You can write this as the nth root of a, and that whole quantity raised to the m power. That's one way you can do it. Or you could also write this as a to the m over n equals the nth root of a to the m. So the only difference is where you're putting the m. It can go outside the radical or it could go inside. And we'll talk different strategies for when which situation is right. So, in order to help you remember this, and to help myself remember it, I always think, because it can be kind of hard to remember, okay, which one's the root and which one's the power. So the bottom one is the root, and I remember that because where do roots grow? In the ground. Okay, so in the ground, so it's on the bottom. Okay, the top is the power, and I think in an hierarchy, the power goes to the person who's on top. That's why I draw a little crown. Okay, so if you're on top, you got the power. This is my fancy crown here. Okay, and then roots grow in the ground. As long as you remember roots grow in the ground, you know the top has got to be the power. Okay? Another thing we want to keep in mind that we talked about before is if you have a negative exponent, do you guys remember how to make that positive? You put it over 1, so 1 over a to the n. Good. Okay, so you never want to have a negative exponent. You always want it to be positive. Okay? Alright, so the next thing says write each expression in radical form and simplify. We're going to do a couple of these. Okay, so the first one is negative 32 to the power of 3/5. So the first thing you're going to do is rewrite it as a root. Okay, now, these you're going to want to do them in your head. You're not always going to have a calculator to do them with. So if you're thinking about whether to put the 3 inside or outside, are you going to want to do negative 32 to the 3rd power in your head? No, no. Because you should already know what's the 5th root of 32. 2. So the fifth root of negative 32 is negative 2. You also know 2 cubed, so negative 2 cubed is negative what? Negative 8. Yay! Okay, this one is really quick. Okay, so we know that if the 1's on top, this is just the cube root of 64. And if you don't know the cube of 64 off the top of your head, that's fine. Let's do the factor tree. So this would be 2 times 4. Or really, you know that 8 is 2 times 2 times 2, right? Okay, so you need 3 to come out. So how many pairs of 2 come out? 2 pairs of 2, so it's going to be 4. Okay, so radical form equals 4. Okay, let's do this last one. This one should be really quick too, because if you have 2, what's your radical? So this is the root. It's the square root to the 5th power. What's the square root of 4? 2. So 2 to the 5th is 32. Okay, so for your homework, it's not going to be due for 2 days, so you can start on it tonight. Okay, if you try to do it in 1 day, it would be a lot. So I would start it tonight, okay, and then you can finish it tonight.